So, good afternoon, students. So, I welcome you in the electronic devices and circuit lecture. Just I want to take the pen. Okay. So, electronic devices and circuit subject. So, I myself, Mr Sushil Sirsat, assistant professor in electronics and telecommunication department. So, directly start with the lecture. So, we have discussed about the what is the difference between FET and BJT in the last lecture. So what are the differences are there? So the differences are there. FET is voltage control, whereas BJT is current control device, and FET is having higher input impedance, BJT having higher input gain itself. Okay, then FET have less sensitive to temperature variation, whereas BJT is more temperature sensitive. Okay, so these are the differences we have seen in the last lecture. So types of FET we have discussed, that is JFET. Then MOSFET. In MOSFET you will find the two types, that is depletion type, enhancement type. Okay, and again it is having two types, again P type, P channel, and N channel. Here again having each is having two types, that is P channel and N channel over here, that we have discussed. So water analogy model we have discussed about this. So directly start with this topic. Okay, so what will happen? So now what we have did is we have connected the drain terminal of the MOSFET, the JFET, junction filled effect transistor, to the positive terminal of VDS. So positive terminal I have connected and negative terminal to my source terminal. Then what will happen? The electron will get attracted. As we are increasing the voltage, more number of electrons will get attracted, but simultaneously here depletion region is there, that is going to be increasing. So what will happen with if you are increasing the voltage? If you are increasing the voltage at certain, suppose 1 volt, 2 volt, 3 volt, 5 volt, 6 volt, and 7 volt, okay, positive voltage, at certain voltage what will happen? Whatever the this depletion region is going to be increasing from both side, and at certain voltage what will happen? These two junction will get overlap. Okay, this depletion region will get overlap, and no electron will flow from this region. No electron will flow, and if electrons are not flowing from this point, then current will not flow. Current will not flow, and this device will stop. This device will stop. The voltage at which the device is stop is called as pinch off voltage. It is called as what? Pinch off voltage. Keep in mind what we are doing. We are increasing the voltage. Just a minute. I will rub this portion first. Okay, rub this portion. We are applying the VDS across this. VDS, that is nothing but the voltage across drain and source. We are applying this voltage across this terminal. Then what will happen? If I am applying voltage across this, so current is going to flow. So 1 volt, 2 volt, 3 volt, 5 volt, 6 volt. At certain voltage, the depletion region is going to be going to be attached over there, and due to this what will happen? Electron will not close to flow, and whatever the voltage of VDS is nothing but the pinch off voltage, that is 4, 5, 6, or depending on the channel itself. If you are using N channel, we have to use the positive, and if we are P type, we will discuss about this afterwards. Okay, so that is nothing but the VP, where and maximum current. Then this is the graph in which we are saying that if we are increasing the voltage, then current is going to be increasing. At certain voltage, the current remain the constant, that is the maximum current, that is called as saturation current or IDSS over there, that we have seen in the last lecture also. So these characteristics are there, in which what we are doing, we are not connected JFET across this, that is nothing but the this gate and gate terminal not connected across this. If you are applying the gate voltage at minus 1 volt, first case we have not applied. Okay, first case here we have not applied the VGS, that is nothing but the 0 volt. If I am applying the negative voltage across this, that is nothing but the minus 1 volt. Okay, minus 1 volt of negative voltage across this, then what will happen? Due to this voltage, whatever this VGS, forget about this VDS over there, this is the VDS voltage. Okay, this is greater than 0. If you are applying less and less voltage, the diode will not get shut off for that one, shut down for this one, this will not turn off. Okay, so the characteristics of this JFET are, this is nothing but the first characteristic. If you are applying the minus 4 volt itself, So less number of current is going to flow from this one. Okay, that is nothing but if you are applying the VGS is equal to minus 4, VGS is equal to minus 4, then less. And if you are applying VGS is equal to what you can say 0 volt, then more current is going to flow. So now I will explain this fact to you. Now if you are applying minus 1 volt, so minus 1 volt applying over there, then this is minus potential across this. Okay, here we are having minus potential. So whatever in this region, this is depletion region, that is nothing but it is having electrons as well as holes, both are there, electrons as well as holes. So now if you are applying negative voltage, then what will happen, the electron at this point are get repelled because it is negative potential across. The electron will get repelled. If you are applying more and more negative voltage, then electron will get repelled, more and more electron will get repelled, and this depletion region is going to be stop very fastly than the first case. That is nothing but 0. If you are applying more negative voltage, then electron will get more attracted, repelled by this one, and this junction will get stop earlier. So this is nothing but the turn off. This device will be turn off. Okay, that is nothing but the 0 current is going to flow. So if at the 0 voltage, the current is maximum flow. If you are increasing minus 1, then current is slowly decreasing. Then again current is slowly decreasing. Again current is slowly again current is slowly decreasing. At this voltage where current is going to be stopped, that is called as pinch off voltage, nothing but my VP over here. That is nothing but the VP over. That is current is going to be 0 in this one. Okay, so if you are observing this graph, you are not getting directly this 4 or 5 graph in your CRO. So we have to take the individual graph, means that is nothing but first about we have to apply VGS is equal to 0, then we are getting current is going to be increasing, more current is going to be at as per this graph at 8 milliampere current, this is milliampere, so this is going to be saturated. Now if you are applying the minus 1 volt at VGS terminal, then less current cause to be flow because that will the junction will reach quickly. Okay, so if you are increasing the voltage, so current is going to be decrease. If you are increasing the voltage in the negative, okay, in the negative format I am saying, okay, then current will be decreasing. So this is nothing but the at 4 volt minus 4 volt, the device will stop. That is called as pinch off voltage. There is 0 current is going to be flow in this. So are you getting? Okay, so we'll move to our next lecture. Next thing. Okay, so if you are having P channel JFET, that is nothing but wherever there is a current conduction is due to the P channel. Okay, this is a P material over there and N, the reverse case. So now I have changed the supply, that is nothing but the minus to my drain terminal and plus to my source terminal. Then current is flowing like this one, means IS will go and ID will come like this one. But what will happen? Here my negative terminal is there. Okay, so holes are getting attracted toward this terminal, and electron will get what? Attracted at this terminal over there. So the current is going to flow in this case. Okay, the characteristics of this one. Now we are increasing. Now at the 0 volt, 0 VGS, we are getting the maximum current, but here some breakdown voltage is there. This is nothing but the breakdown. That is nothing but the junction will break down and current is maximum current cause to flow. Then if you are applying the positive VGS, then again this will happen. Again we are adding some positive voltage, the current will cause to flow. Okay, these are the symbol of JFET. That is nothing but the arrow is inside indicate that it is nothing but the N channel JFET. Arrow is inside. Okay, this is the symbol of my BJT. Arrow is outside, that is nothing but the N channel, and if my arrow is inside, that is nothing but the NPN transistor. Sorry, PNP. This is PNP, and this is my NPN transistor. Okay, this is my NPN, and this is nothing but my PNP transistor over there. And here in the JFET, that is nothing but the N channel and P channel. So arrow is inside and arrow is outside indicate my P channel JFET. So this is all about JFET characteristics and all we have discussed in this lecture. So from next lecture we will discuss about the MOSFET and all that. So thank you very much for attending this lecture. Thank you.